Hey guys, welcome to another episode of Flip and Customize. And behind me we have our 99 Dodge Ram Cummins diesel with the early 24 valve in it. And what's going on is it's not starting well at all in the cold. Now I recently picked this truck up. We have a whole playlist as to the build and what we're going to be doing to this truck, so stay tuned for that. But to start with, we're just kind of fixing the very basics on it. And we had to fix the shift cable as well on it because it was stuck in first gear. But what's going on now is the heating element. These trucks have a heating element right in the air horn into the intake itself, and it superheats the air. There's a lot of current that gets thrown through these things. They're powered by two solenoids, which are down here on the driver's side, right? And it's hard to see them. I apologize, but they're right there. There's one here, one there. There's two solenoids, okay? You get down there. There you go. See the two solenoids? They look like a regular old starter solenoid, and what powers those solenoids is you should have battery voltage on one side of those solenoids at all times, because you have a connection here, and then that connection which feeds through two fusible links, and those fail, unfortunately, and it feeds the coil itself. So what happens is, say these are good, you get battery voltage there, you turn your key on, you get a wait to start light, and what happens is that solenoid engages and it's pulling the battery voltage all the way through to the positive terminals on this side of the intake horn, and it's heating the two elements in here, okay? So what's going on with this one is when we check it with a voltmeter, we get 12 volts right here coming directly off the battery when the key is in the off position. However, when the key is in the on position, it drops to almost nothing, like 0.2 volts. That doesn't sound right, because I'm like, all right, well, the battery's fairly new, the battery's good. What's going on with our truck is this fusible link, the suspect, is bad, and apparently there is these are discontinued. I'm not sure, I'd have to research it. There is part numbers right on it. So what I'm gonna do is I'll kind of show you what we did to figure this out, just some basic troubleshooting steps, and then when I figure out if we can get a new fusible link or what we have to do to get this thing going again, I will post that, because basically to prove everything works, we jumped out the relay and put power on the other side, which is not getting to, so on the side that it would be fed to, and we get power right to the heating elements, and it gets warm, it's heating up, so we know the elements are good. So let me show you what we're talking about. First, we got our multimeter set on the DC volts, okay? And we're gonna go over here. That's a known ground as well. You can check your ground on your elements, make sure that's good. But these are the two terminals. So what should happen, now that you're gonna use this on a cold engine, so your preheat element is gonna want to work to begin with. You're gonna hear, if these solenoids are working, you're gonna hear them click in. So that's another thing you can tell. A quick check you can do, you can either hear them, you can put your hand on them, and you'll feel them. But what you should see right here, so I'm on one of the terminals, okay, and we'll check them both, is when my son Evan here, when he cycles the key to on, you should see battery voltage. And just to prove everything's working, we got battery voltage, okay? So I'm gonna come over here and go ahead and cycle the key, Evan. We get like 0.2 volts, shut it off. And so that's next to nothing on that terminal. And we'll go ahead and check the other one. Oh. And go ahead. Even less. Okay. Shut it off. All right, so we know we're not getting power to our elements. Now, what you can do is go down here to check your wiring on your solenoid. So now I'm on this is hard to do, but I'm going to show you. So on this solenoid, on the power side of the solenoid, sorry, let me get this moved. I hope you can see it. Yeah, it looks like you can see it now. But on the power side, this is the side that feeds the element. So I can't show you the meter at the same time, but I can tell you right now we get nothing because the key's not cycled. Go ahead and cycle the key. Same thing, 0.2. So we're getting the same voltage down here on the feed side of the terminal as we are at the element. So nothing's changed there. Now, let's go on the battery side of the terminal. And what I did was I connected a jumper wire on the battery side just so we can clip it onto our terminal, like so. Therefore, I don't have to be reaching down there. So this is nothing more. We did nothing more than extend that connection down there. This is the battery side. So therefore, I say battery side. We're connected now, and we're grounded. I'm grounded right to the terminal, and we're seeing battery voltage. So what should happen when he cycles the key is this should drop to like 7 or 8 volts because it's such a high draw, and this thing draws so much current, these heating elements, when they're working. However, if it just drops right off to nothing, something ain't right. And what I mean by something ain't right, you better suspect your fusible links in these feed wires, because that's what's going on with this one. So go ahead and cycle the key forward. 0.2 volts, it drops to nothing. However, if you go over here to your battery, leave it on, Evan, the battery is still good. So we've lost, through this link, there's enough voltage getting through it when the key is not on and it's not pushing any current through it to read battery voltage. But as soon as you turn the key on and you try to go ahead and get current pushing through it, it can't get through it because the links are blown. So this truck needs new feed wires that go right off the battery to the solenoid. Now, I've been told they're discontinued. There's got to be a fix out there, even if it's me making my own cables, once I figure out the rating of these fusible links. I will post what we did, as well as any part numbers I find in the description. So, one last check you can do, just to prove your elements work, is we're going to actually go ahead, since we're not getting power to the supply, what feeds your elements, we're not getting power to that side, or we're only getting 0.2 volts. But we want to know if this element is in fact getting power from this wire to here. You go ahead and we're going to connect a 12 volt source right to that. So I'm going to use my booster pack there. We'll connect it right to this side, and then we'll come over here. When he cycles the key, sorry, I just messed that up. So we're going to connect it to the battery side. So therefore, it's going to actually test the solenoid as well. I apologize for that. So he's going to connect it to the battery side with the booster pack. That's simulating 12 volts. It's basically taking this wire, the link, right out of the situation. And as soon as he cycles the key, we should see somewhere around 8 volts on this side because it's such a high amperage draw, as well as up here on this side of the heating element, the power side. So let me get the battery booster hooked up and I'll show you. All right, guys, we got the booster hooked up, and what we've done is we've hooked it up to the feed side of the solenoid down there. So what that does is taking this power supply directly off the battery and taking it out of the loop. And I know those connections look terrible. And what it's going to do is when he cycles the key, we're going to get 12 volts to the other side of the wire, which is feeding this element directly, and we should have that battery voltage. However, it's going to drop to around 8 volts because of the draw these elements take. Therefore, you know you're getting power to the element and your solenoid's working. So we're just basically troubleshooting and taking everything out of the loop. So right now, we have nothing at this terminal. Go ahead and cycle the key. I'm expecting around 8 volts. That's just about 8 volts. Therefore, there's power getting to this. Now, is the element itself working? Well, it's an easy way to check, and it gets warm. So to the touch right now, this element is getting warm. So this thing is in fact working. The solenoids are working. It's allowing it to get through, like what we want. However, what the problem is we lost power from the battery to the feed side of that solenoid. So we have a bad fusible link. So therefore, we're going to get the fusible link ordered and or find a replacement, or how we're going to fix that. All right, guys, here's an update. So after some research on this whole heating element and this harness, because we determined by troubleshooting that the fusible link is actually what's bad in these things. And I found the part number, had a hard time finding a part anywheres. So that could be a problem as well. So what I did is I went ahead and sourced some fusible link wire. And I'll show you that right here. So what this is 12 gauge fusible link. This is not regular wire. This is fusible link wire. And a general rule of thumb on this thing is you want the fusible link wire, because this is 12 gauge. You see it's pulled out the back, but anyway, this is 12 gauge. So it's about 4 wire sizes smaller than the wire you're trying to protect. That's a general rule of thumb with fusible links. So the main harness where it connects to the relay down there is 8 gauge wire. So we went with 12 gauge fusible link wire. which is also what the OEM harness had on it, which I think honestly the problem with it is just so corroded internally. It's just no good. There's just such a high resistance on it. So with that being said, what you also want to do is keep the length consistent, the fusible link wire length consistent with the original wire. You don't want to add a ton of fusible link wire and either negatively impact the protection capacity of the fusible link. So try to stay consistent with that. So what I'm going to do now is I'm just going to go ahead and pull the harness right off. It's just 2 connections on the relay and on the battery itself. And then we're going to go inside, and you could crimp this on, but I'm probably going to end up soldering it on. And then the only other thing I might do, I'm thinking about doing, is because it's kind of messy and crappy looking all the way up here to the battery, is this a power stud under here? We might run it right down to there. It would clean things up as well and look better. So there's no difference as long as it's getting something from the main power supply. So let me go ahead and get this thing off, and then we'll make our new harness. Back in the shop now, and that's the part number for the link itself, just so you guys can see it. I'm going to put it in the description too. Oh, that's not focused or what? It's hard to tell. But I'll put it in the description. But anyway, this is the 8-gauge wire section of the harness, and it's just literally just 2 battery connections, basically. Two 8-gauge wires that are spliced into a piece of fusible link, which is the 12-gauge fusible link wire that we got. And I'll put a link to that as well. Actually, you can buy this pretty much anywhere. But what I'm going to do now is I'm going to strip this heat shrink they put over it back and disconnect it or cut it, re-strip the main wire, and get this new piece put in there with a new end crimped on it. Probably 2 separate ends, we'll see, and go from there. Alright guys, before I go too far, I already went ahead and soldered this fusible link in. About 6 inches is about what it was with the old one after we cut a little off from it. But then I put heat shrink right over it, 2 layers of it as well, so it's some good chafing as well. And then I crimped on a connection at the end here, and I actually soldered that as well. But this side I didn't do, just so you can see it. The soldering is not the best, I'm not going to lie, because one of my soldering irons died. And I had to use a supplementary one, so it's what it is. So now I'll heat shrink that with 2 layers. I will go ahead and crimp on our terminal, and then we're good to go to put this back on the truck and test it. So again, it's nothing fancy. This is straight up just a piece of 8-gauge wire with ends on it and fusible links. So, I mean, I think I found a couple used for like 80 bucks on eBay. So just be aware, that's all. Especially if this does work. We're going to find out in a minute. Save yourself a ton of money if you're willing to put the time in. All right, guys. We got our new wiring harness all made up. These 2 ends go back down there, 1 on each relay down on there, 1 on each terminal. So go ahead and clean. This is a good time to clean the terminals as well to make sure they are clean. I went ahead and did that. And the other end, or these 2 ends here, they go to the positive side of the battery. Here, what I'm going to do is I'm actually going to run them under here because it's a cleaner look. So route them up underneath here. So I'm going to remove this, put these here, and the other end down onto the relays, and we'll test it with our meter and see if we're actually getting power to the heating element. All right, here it is. So they are actually, I rerouted this one because it was like routed up over these brake lines, so that didn't really work. The booster line, so we rerouted the main power wire, which has nothing to do with anything. And there's our 2 fusible links connected right under that positive terminal. Again, this is just another place to tap into this battery positive. It's a little cleaner and it'll go right under this cover. The other end is right on our top of our relays. 1 here and 1 there. I know the lighting's not the best, but it's just simply that, the relays. Now to prove that and to test it to see if it works, is the other end of those relays, when you key on and those relays click in, is sending power to the heat grid, which is right here. So let me get this wire out of the way. You can kind of see it. I just tapped into it with a alligator clip. So there's a stud here and a stud here on the back side of your intake, and there's 2 heating elements in here. So each one of those relays controls one of them. So I got that connected there, and the other end's connected to my meter, and then the meter, the ground is connected there, and we just go ahead and turn it on. And what we're looking for is we want 12 volts getting to that heating element with the key on. So here goes nothing. Let's find the key first of all. This truck's been sitting for a week or so, so hopefully, I hope you can see that, we get battery voltage right to the heating element right now. So it's showing like 10 volts, but that's accurate with the drawer of these heating elements. And then you'll see it click off and the voltage will go away after it goes through its heat cycle. Boom, voltage goes away. So that is working. And then to prove it, just come out here and put your hand on it and it should be warm. Oops, I can't find it. And it is. So that's a good thing. So the only other thing we can do is to go ahead and test the other one, so which would be over here, and we'd want to do the same exact thing we just did, and to make sure that that is indeed getting voltage with the key cycle on as well. So again, I just switched it over to the other terminal, which is testing the other heat element to make sure we're getting voltage there. And it is about 10 volts, 9-10 volts, because that's a pretty significant draw. And again, that'll shut off when it goes through its cycle. And once it goes through its cycle, boom, voltage goes away, come out, and it should be warm. Obviously still warm, but it's gonna be warm. And it is. So that's a win right there, boys. That is a win. The thing you wanna do is make sure once you've proved it, and you're getting voltage here and it is nice and warm now, because those are huge draw. And again, you're protecting this 8-gauge main heater circuit harness with these 12-gauge fusible links. And what that's going to do is, if there is a problem with the circuit, these are going to burn up and let go to protect the rest of the circuit and to protect your vehicle. So what we've done there is we've done a repair. We basically just replaced those bad 12-gauge fusible links with some new ones that we sourced. I think I sourced these ones on eBay. I got a 4-foot roll of it, so obviously way more than I needed. And it was very cheap with some new crimped ends and some heat shrink. I think you're into it for like, I don't know, 20 bucks. And your time, and you learned something, and you did it on your own, and you didn't have to go buy a used one that could potentially be bad for 80 bucks on eBay. If you can find a new one, it's $100+, because there's guys that are making them. It's pretty simple. So with that being said, guys, we went ahead and fixed our cold start issue on this 99 Dodge Cummins with the 24 valve on the heat preheat element on these trucks. I know a lot of guys take them out up here in Maine. It's cold. I'm leaving it in. I want it to work. It starts way better when it's cold, and I don't have to plug the truck in half as much. So that's what we did. We replaced the fusible links. We fixed this heating element circuit to get this thing working, get this truck up and going. So if you liked it, go ahead and please subscribe. Give us a follow. We really appreciate it and help us grow. Thanks again. Flippin' Customized.